Hello everyone, it's Caller from 19. Today's day 82 in my challenge day. And after the last video, I read some about how to create a top level acceleration structure and some other GLSL features about the layout specifier and a qualifier, and also the storage qualifier concept in the GLSL. So before I start, I'm going to recap and review these concepts first. Okay, so about the acceleration structure. So to accelerate the ray tracing algorithms about the computing the ray mass intersection, we need to use the bounding volume hierarchy that reduces the number of intersection checking. And the Vulkan API provides us two interfaces to access this hierarchy, this bounding volume hierarchy, with the bottom level acceleration structure and the top level acceleration structure, shortly BLAS and TLAS. And BLAS is simply the acceleration structures of triangles. It, it requires some specification to create BLAS. The first one is the location of vertex and index buffers on the GPU. This is the location in terms of memory. And the memory layout of the vertices, each vertex has is a stride and offset. Offset means that where it starts from, where the data starts from, relatively between the other vertices. And the stride means the how can I explain this? Some kind of gap uh, that it in charge in the whole memory space. It has some kind of gap between the each vertex. Sorry for a bad explanation. And the format of indices is usually you assign the integers 30 bits, a number of vertices, and geometry data. We can uh, represent geometry data as a triangle or the triangle fan or triangle strip, some other primitives as we want, and number of triangles in the scene, and the start and end of triangles, and performance priority flag. It means that it's about whether we focusing on the performance on the face of building acceleration structure or on the face of tracing ray. So if we want to trace ray faster than another acceleration structure, it may take a longer build time, but in the runtime, we will trace fast because we create the BLAS with this flag. And there can be there is some optional flag, which is a compaction flag and an updatable flag. Yeah, these all the specification is required for VLAS. The TLAS is more simple. So TLAS is the structures of instances. In the scene, we have a lot of instances, and each instances can be a copy of VLAS. So each instance is point to the VLAS is related to itself. And an instance point to a BLAS and includes a transformation matrix represented as a 3 by 4 affine matrix and form some kind of rotation and translation. What are those? Skewing and also the scaling something, the kind of transformation. In the specs for TLAS, uh, as I already mentioned, we need to specify the reference of BLAS. Exactly is a device address of the BLAS, and these can be carried by extension function and also transformation matrix and instance custom index. This is an arbitrary 24-bit number that can be carried when there is an intersection between Ray and the BLAS. Also, we can get this information by using this extension function. And this is interesting thing that we can use in the ray tracing pipeline. That is instance shader binding table record offset, and it's designed for to store is designed for ray tracing pipeline to store an offset for looking up material shaders because some of instance there can be a lot of copies of that, and each of instances can have may have may be able to have different materials for each surfaces. And also, if the instances have different materials, we need to specify. Um, we need to write some algorithms, different algorithms that reflect the light or absorb light or the refracted light, depending on the materials on the surface. So this can be useful in the case, and also PK geometry instance flag and mask. And the next thing is some slight GLSL features. So there's a version specifier. So we need to specify version of GLSL that we want to use in the first line of GLSL shader code. Also, we can add extension by following this Greml. For example, hash extension name is some kind of the GL extern ray array. And if we want to require the the extension in the application always, we can specify the require keyword, or if we want to just use it, if we want to just use the extension, whether it is regardless of necessariness. So in this case, we can just specify the enable keyword here. And there's a layout qualifiers to specify the information for descriptor in full con. And storage qualifier are keywords such as a buffer and a uniform. These are some kind of long, so I will stop here. So let's start next chapters. This points to the right. So we are going to use object coordinate system. Uh, in this coordinate system, x-axis points to left. No, right. Positive x-axis point to right. Positive y-axis points to up. Positive t-axis points to backward. So the unit of pixel is 1 by 1, and it points to the top left corner of the pixel initially. So we need to first uh, pixel x, center of cell 0. So we want to transform the screen UV coordinate into the coordinate with the origin as 0, 0. So in this case, we need to translate this screen coordinate resolution by subtracting each of the height and width with the half of width and half of height. So in the case, the top left corner was 0, 0. But in this case, if we subtract the appropriate half of width and half of height, we can translate the as much as the subtraction amount. So the case the origin of the transformed UV coordinate will be point 2. We'll have the origin as 0, comma 0. Translate the coordinates. Such as resolution minus solution. And then we can normalize the coordinates. XY2, sorry. So the initial range was minus resolution for 2, resolution 2. And we want to normalize the coordinate against the y, the the length of y. So in this case, the normalized coordinate will be minus resolution y. No, sorry. This would be 1 by minus 1 to 1 would be a minus a to a, where a is called aspect ratio. 2. So let's remove 1. We remove these parts. This is with 2. So this is our final resolution UV coordinates. Yeah. If the precision of floating points, let's keep the numerical operation. think that is this for So this full vertical slope is the a way to extend our screen by multiplying this full vertical slope to the screen coordinate in each component. For example, if the x component and the y component is above beyond the 0, comma 0, which is the origin, will be extended toward upside. On the other hand, if the coordinate is located below the origin, it will be extended into the the downside. So the case we can extend the screen coordinate to the both side of the both side of upward and the downward. Survey seems in these reviews are recurring. We keep track of the closest intersection, and when these two ratios, we'll be able to find information about this closest intersection. So finally, we need to query the query function to trace the rays and uh, compute the closest intersection between the ray and the mesh in the scene in the computer shader. GLSL external ray query extension. Just to customize speed up search sections. Ray can only, this is really important feature in the ray query. Array can only intersect it with the instance if set the position of both uh, ray mask and instance mask field. Provide instances in the tricky for level of details for the tertiary non-zero trace particle level. Great version. Minimum team without. So this T mean and T max variable, which is composed of the range of ray, it enables us to stop the ray tracing algorithms by preventing the infinite search in the space. Because there can be no objects at all at the direction of this current ray. So in this case, we don't need to search just indefinite distance in the space by just controlling the distance of the ray, not going further. So now we can call it current. Flags. Back. P mean is 0, 0, 0.0, right direction. The max is 10,000.1. Very first answer in the book. Normally, every time we call this one, the requested in this intersection. to find the close intersection between cars without executing a code within the block. Using a while loop here. Mm, mm. Okay, today I recap some of the chimera algorithms in the ray tracing and also define some of the screen UV coordinate and I tried calling some ray query functions like to initialize the ray query object. I call the ray query initialize extend and also to update the committed intersection. I call the ray query proceed extensions. And finally, we could get the t coefficient of the ray, which means the distance of the ray. And by calling the ray query get intersection t exponential function. So hopefully you guys enjoy this video, and I think I can show you guys the actual finally the ray trace image in this week. I hope so. So thanks for your watching and see you next video. Bye bye.